We're going to take a look at the Testo 570, and I'm going to go ahead and hook this up, and we're going to take a look at what it does. Testo 570 is a higher end Testo instrument, 4-valve manifolds, 2 temperature sensors. Works with any of the Testo printers here. I've got an older Testo printer here. I didn't have a new one. And Easy Cool software, which I'm going to hook up also so we can show how that works. But this is what the typical kit looks. So this is my own 16 SEER unit. Believe it or not, I just put this thing in this spring, and I sort of disgusted here when I opened it up. Took a look at the condenser coil here. It's just plugged solid with cottonwood and dirt. We had a really heavy pollen season here in Ohio, so actually we're going to do a couple recordings here. I'm going to do a test in and a test out on this so we can actually take a look at the difference in the results. Alright, before we power up the 570, you have to have all the peripherals hooked up to it, because it's going to go out and look to see what temperature probes are attached. And I'm going to go ahead and power this thing up here. The unit's obviously just cycled off here, so I got to get it started back up again also, but I'm going to power it up and we'll start going through the menus. Alright, so I just got this thing turned back on, and I'm going to go ahead and turn the power on here. And we're going to see the whole menu lights up for a second. And I'm going to go ahead and turn the backlight on just so it's a little bit more visible. And you can see here I got my evaporating temperature, my condensing temperature, my low side pressure, and my high side pressure. And if I scroll up here, I got T1 temperature 46 and 82 on the high side, liquid line. And then I got no superheat right now, and I'm showing 344 degrees of subcooling. Now that should indicate there's a problem right away, and the problem happens to be is that I have the refrigerant set wrong. So I'm going to go ahead and push set here, and it says refrigerant, push OK, and I'm going to change that to 410A and hit OK, and then hit OK again, escape, sorry. Okay, so now I'm at 410A. And you can see my evaporating temperature is 41.9, and my condensing temp's about 99. T1, T2 temperatures. Now that's looking a little bit better. Here's my superheat and my subcooling. And I'm running about 8.5 degrees of superheat. And again, I just started this machine up. So we got to give it a little bit of time to settle out. Now one thing I would note here is, let me look at my condensing temp. It's about a 99 degree condensing temp, and it's about 80 degrees outside here. So you know, we're a little bit higher, just looking at general at what the temperatures are, and it's obviously because we got a plugged up condenser. But one thing to note is, even though that condenser is plugged up, that's not going to affect the subcooling reading, because we're just going to get the same subcooling at a higher condensing temperature. The other thing that we need to do is on this, before we get too far, is we need to make sure that our probes are set up correctly. So I'm going to go into settings again. I'm going to scroll down until I see the pressure mode, vacuum, weight, measuring, daytime language, probe type. And I need to change this from immersion probe to a surface probe and hit OK, because there's an offset for temperature built into the machine here. I'm going to hit escape, come back out now. And what that's going to do is it's going to compensate for the outdoor air temperature, and it's going to offset those probes by probably a couple of degrees, which is what it's going to do is increase the accuracy of the instrument. And you know, that's our basic initial walkthrough in the menus. And there's a couple other cool things I want to show you with this. So I'm going to pause and regroup here for just a second. Okay, one of the cool things is with this instrument is it allows us to print. And if I hit the print key here, and I go down to signal measurement, hit OK, I have to scroll down to print and hit OK, and it's going to shoot a signal out via IR when I hit print to the printer, and it's going to print out the unit model number, the serial number, the firmware version, the pressures, the temperatures, and superheat and the subcooling. We'll give this just a second here. I haven't tested it with the newer printers to see if the newer printers are any faster or not. So we'll let that refocus here. And you can see there we got our superheat, our subcooling. Cool thing is we can print out our name and address on here, so the company name can be put onto that report if you want to put it on there. And we'll back this up just a little bit so it focuses better. There we go. You can see we got the Testo 570, the serial number of the instruments, the pressures, corresponding temperatures, and the company address. Right in the top of the 570 there is a USB connection, a mini USB, and I just have that plugged into the top and plugged right into the PC, and we're going to take a look at the software. Alright, so as soon as GetCool gets up here, you can see we got a Testo 570 connected, and I'm going to go in and go to the connection manager, hit the right mouse key here, and go into the real-time measurement. Okay, so now what we've got here is I can look at my chart, and I'm going to go ahead and push. Actually, let's take a look at display first. Your PC is too slow. Measurement data are lost. Please increase measurement cycle. Alright, so I'm going to take this up to a 2-second measurement cycle. And I'm going to push stop. Start here again. Delete the previous measurements. And I'm going to go to display. And you can see right here, now what I've got is all my icons on my display. Got my pressure, my corresponding evaporating temp, my high side pressure, my corresponding condensing temp, temperature probe 1, superheat calculated off probe 1, temperature probe 2, subcooling calculated off probe 2, and then the difference between the two probes. If I go in here to my chart, it starts graphing these things graphically on the chart, and I think I'm as wide open as I can get on my screen here. Now there we go. Now I've got some pretty consistent readings there. Everything's pretty smooth. I'm going to just block the condenser off for a second so we can see what happens. I'm just put a panel on top of the condenser for a second. And we'll zoom back in on that. And what we're starting to see now is the high side pressure is going up. And we're seeing the changes on our high side and we're seeing really no change on our low side at all. I've got quite a few lines here. I'm actually going to drop a few of these things off here, and I have to do that. I got to stop the readings. All right, so now what I've got is got this thing set up here, and I'm going to go ahead and push the start button and delete the previous values. And I'm going to go to the chart here. And you can see right now I have nothing showing on my chart. If I click scale 1, which I have it set up for scale 1, we scroll up a little bit here. Let's see here, scale 1, come on. Okay, I have it set up for PO and PC. It's just the pressure low and the pressure high, the blue and the maroon here. Which you can see that I'm running right at, on the blue line, somewhere around 125, and on the high side around 310 or so. And what we're looking at is, pretty much how consistent the pressures are. Now I can click on scale 2 and add a bunch more lines to the graph, but at this point I really don't care about pressures. You can see the graph auto rescaling, so I'm just going to knock those pressures off there. And I'm going to scroll down a little bit so you can see here. And I'm going to actually shut off this other scale here down at the bottom I have activated. It's going to drop a few more lines off the graph. And make sure there's nothing else activated. Scale 3. Let me shut that off. Alright. Scale 4. Scale. Alright, so right now, see what I have on here. Scale 1, scale 2's on, scale 3, scale 4's off. Okay. So right now I should have 1, 2, 3, 4 lines in the graph, and I have actually 1, 2, 3, 4, 5, 6 lines on the graph. I'm also showing this yellow line, and I'm showing the yellow and the black line, which is T1, T2 temperatures. Let me see what's going on here with those. Finger mouse, I hate it. Cycle them on and off once. A little bug there. Alright, it looks like just because I had them on and off, I had to cycle them once. So now what I can see is my evaporating temp, my condensing temp, my superheat, and my subcooling. Now I'm going to go ahead and block that condenser again. And what we should start seeing now is obviously the high side pressure is coming up, and we're also seeing our subcooling increasing. And we know that's really not possible. What's happening is the temperature probes take time to respond. So we're driving our pressure up basically faster than our temperature can measure. That'll start to settle out in just a minute. And you can see our superheat starting to drop just a hair on that graph. And that's simply because we're driving a little bit more through the valve. We'll give that a few seconds here to run, and we'll see our subcooling. It should start to drop back down again. Because we're going to get basically the same subcooling at a new saturation temperature. Alright, well, this is interesting because basically what we're seeing here is the effect of an oversized condenser. That subcooling is actually showing an increase because we have a higher saturation temperature, higher condensing temperature. Let me move this panel so it's not vibrating so much. It's higher condensing temperature, but our liquid really couldn't get any cooler than it's running. Let me take a look at T2, which is the orange line, and you can see there, even though I blocked the condenser off, there's only a really small change in liquid temperature, because the condenser, even though it's plugged with dirt, even though it's it's 80 degrees or so out here right now, it's really, the condenser is so oversized on these newer units that's really not changing it much. Now, if you look closely at that brown line, you can see it is trending down a little bit, but that's about all you can say on there. Our evaporating temperatures are staying about the same. Our superheat still staying around 9 degrees. Subcooling, though, is up at 31.5 degrees of subcooling. And it's going down. If you watch it there, you'll see it dropping. I only have it set for every 3 seconds. It's dropping slowly. Whoops, go back to the chart here. But not all that much. So what we're seeing here is essentially what would appear to be an overcharged unit. And in fact, it's just a dirty condenser. And if I get that condenser cleaned, in this case, get the blockage off of it, what we're going to see is the pressure is going to drop. The liquid can't really get any cooler again than it is. It's going to stay about the same temperature, and our subcooling will fall right back in line. You see, our superheat's really sort of a nice flat line across the bottom here, and this is an 16 SEER ream unit, and so it's the first time I really looked at it like this, and it sort of caught me off guard. It's not a normal characteristic I've seen before with these types of units, so just something new. Alright, so I pulled that blockage back off there. You can see my subcooling starting to drop again. And again, look at that liquid temperature line. That liquid temperature is barely changing at all. So what we're seeing, when we had a dirty condenser or block condenser in this case, was we saw a significant increase in pressure, and we're seeing a huge drop back down here in the subcooling. Back towards normal here, or what would appear to be normal. Let me go back to the display here. Around 16 degrees of subcooling. Smack the spider in my arm. And then back to the chart here, you can see that's all acting pretty normal. The superheat side, again, it's pretty much remaining constant. Superheat's running 11.2, 10.8, it's dropping down a little bit right now. But you can see what happened here. Again, it's a pretty interesting characteristic of this unit. Oversized condenser, increasing the pressure, which would also increase our wattage, definitely, because the compressor's working harder. We're going to see a increased compression ratio, increased electrical usage. Boy, if I were walking up this first time, I might have dumped some gas out of it, not even knowing any better, thinking it was way overcharged. even looking at the dirty condenser, because typically subcooling does not change with pressure. It's just again an oversized condenser.